Yeah. Hello, everyone. So, in this talk, we'll be mainly discussing about quantization of LLM models and sharding, how it works in PyTorch and in ML itself. So, I'll be sharing a relevant paper also. For it. So, to understand what QLoRa is, uh, this paper, like efficient fine tuning of quantized LLMs. Uh, this is written by Tim Detmers and his team from University of Washington. So basically, to dive deeper into this topic, we have other papers to reference from. I'll switch to the other paper in a while. Uh, so this is QLoRa. It is a technique used for fine-tuning very large models like 65 billion parameter models on a single 48 GB GPU. So preserving the entire model performance. So how it does this, we'll dive deeper into this. So technique is like since these models are quite huge to fine tune on entire model size, so there's techniques for this. Yeah. Fine tuning of these LLMs can take very high computation time and resources. So uh, instead of if we fine tune the Llama 65 billion parameter on the 16-bit fine tuning, we can see that it would require more than 780 GBs of GPU memory. So that is not something practically possible, or maybe it will be highly very computationally expensive. So we'll move on to better options of doing this. So we use 4-bit quantization. So what is 4-bit quantization and what is QLoRa? So quantized LoRa, low rank adaptation. So we'll understand this, and I will dive deeper here. But I'll first share the relevant LoRa paper also. Yeah. So low rank adaptation of large language models. So this is a paper by Microsoft. So they have introduced the LoRa technique. So uh, the QLoRa is an advancement of this same research. So what they have done in this paper is these large models like GPT-2, Roberta, GPT-3, these are 175 billion parameter models. These are quite huge to train on uh, maybe a few several GPUs, or it is very computationally expensive. So what we do is we use pre-trained. We take the pre-trained weights, then we compress those weights using LoRa technique, and uh, then we get those updated decomposed weights, and we train using those weights. So how this works, I'll walk you through the math behind that. Really sorry for that. Yeah. So basically, instead of going into the mathematics here, which is quite would be difficult to understand at this level, I will I'll just keep the QLoRa paper, and I'll explain you how it works. So LoRa is low rank adaptation. It is used to decompose the weight matrix into uh, a smaller rank matrix. Rank is defined by the rows and columns which are linearly independent for that weight matrix. So and a smaller weight matrix is then used for fine tuning purposes. And so you keeping the size of the model lower and compressing the weights, you can still achieve the same or significantly better performance using this. It with the quantization and LoRa, there is no significant degradation in the model performance. So these are the models which are recently released. So given Kaneko, Wikina, ChatGPT, Bard. So these are the quite large size models. So how quantization works? So 4-bit normal float. This is a normal 4-bit integer float number. And if we if you understand the architecture, this. Uh, so this is the base model, the 16-bit model, which would be a large size model. So what we do here is how the fine tuning works basically. We take the weights from this. We fine tune the weights, which are the adapter weights, and it is an optimizer is the base function on this. So uh, how uh, how you want the fine tuning to work, like which layers you want basically to fine tune. So only maybe 8 to 10% of the layers of the model will be fine tuned. So how this works is uh, the 16-bit transformer, it is decomposed into a 4-bit matrices, and these are fine tuned where the matrix elements are most of the elements are frozen, a few are the select ones are fine tuned, and then the quantized weights are converted back to the 16-bit so that we can do inferencing on that. So it is not directly possible to inference on the 4-bit model. So we convert to the 4-bit to fine tune it and uh, save on the memory intensive workload, and then we convert it back to FP16 or FP32, so which is a floating point 16-bit or 32-bit, and then we can do inferencing on the model. So this is so basically, we can understand this k bit. So k can be anything like 8-bit or 4-bit. So we'll understand for an 8-bit how it works. So there's a range of 127 to minus 127 to 127 for an int8 type tensor. So for a 32-bit number, we have this. We calculate the absolute for this value, and we round off the value here. So we get the equivalent for this int8 tensor from this 32-bit. So we convert the FP32 to int8. So it is 8-bit quantization. So how this works is it for the 8 int8 there are 8 equidistant values which are calculated, and for the from the 32-bit value it finds an equivalent in the 8-bit for the 8-bit, and then it converts it decomposes basically into the smaller value. So uh, we uh, we we still have the same value stored, but in a lower precision format. So instead of using a point 3333, we have a 0.33 or 0.3. It might lose out a slight precision value, but it keeps the function and weights intact. So we so this is how quantization basically works. And LoRa, so low rank adaptation. So low rank adaptation is a fine tuning framework basically. So adapters this so how this QLoRa fine tuning works. I'll walk you through the I'll walk you through the code as well once we are done with the paper. Uh, yeah. So there's I'll cover the PEF topic once we are done with the QLoRa. Yeah, I'll
So
share
basically,
the
a mathematical transformation logic, huh?
yeah. It is mathematical for converting the weight matrices into a smaller rank matrix. So it actually works on the backend. So how models are decoded into binary and the matrices in this how the weight matrix are updated, like when we are fine tuning the model. So we can understand this basically.
So one quick question, Mihir.
Yeah, sure.
Sorry, with my limited understanding. So normally, any Hugging Face model, or let's say even PyTorch model, right? Initial
Yeah.
PyTorch model, in order to have it normalized in different across different frameworks, we used to convert it into different intent winnow or ONNX, right?
Yeah, yeah.
So, just wanted to understand what is the difference between that, because according to my understanding, ONNX also does that quantization.
Hmm.
The weight reduction or something, right?
Yeah,
Is there
yeah.
any difference between these two processes, quantization and ONNX conversion, or those kind of framework conversion?
No, no, no. Quantization is same across these platform, methods. Like so, in Onyx and PyTorch and in other. So sharding in PyTorch is a little bit different. I'll explain to that as well. And so, so understanding how like basically the quantization is working. Like uh, fine tuning is fine. There are different ways for fine tuning basically, and fine tuning using the LoRa and this, it is done through this process. I cannot comment about any other alternative, but if you have any relevant questions, I'll sure pick up. Yeah. Uh, Vivek, should I go with the code demo or? Yeah.
Yeah, as per your own pace.
Sure, sure. We'll have a walkthrough of how we fine-tune model of Falcon 7B using this. But so we will also require the PEFT library. So I'll cover the PEFT. I'll give an overview of the PEFT this also paper. So this is also a parameter efficient fine-tuning. So efficient transfer learning. So this is quite uh, used for this fine-tuning. So basically how PEFT work is there is an adapter hub. So adapter weights are used to for fine tuning. So how fine tuning basically operates is this adapter weights are updated once when the learning process happens. So in the forward pass, the model makes the predictions, and in the back propagation, the backward pass, the weights are updated in the system. So in the layers. Most of the layers are kept frozen, and the single layer is updated. So this happens in a loop for the number of epochs you are training the model for. Yeah. So I'll walk you through. So you can have a reference later on for this PEFT paper also. Uh, what I'll be showing in the code demo is implementation of this PEFT and LoRa library in for the uh, uh, Llama 2 paper, and using the Llama 2 model and a Guanaco model. So basically fine tuning the Falcon model, Falcon 7B and Llama 2 7B model on this using QLoRa and PEP. So I'll walk you through the demo also. So what we need to do, I'll not run each and every cell, so because it will take a lot of time running this. So since all the outputs are would be visible, I'll walk you through the code. Okay. Uh, so you will be using accelerate, PEFT library, transformers, datasets, and bits and bytes. So bits and bytes is used for the quantization. This is used to quantize the base model into the 4-bit model equivalent for this. And accelerate and PEFT. Accelerate is also a library from Hugging Face, so it is used for parallelism and training, fine tuning. Uh, so once we have all the libraries and dependencies installed, uh, we also need to import the data set will be training on. So this is an Guanaco is a data set from Tim Deckmer. So the author for QLoRa's paper. So he has published the data set on the Hugging Face, so you can have a look. So this data set basically is of mixed examples on training, translation, text related question answering data set. So it can answer. It can be more closed end Q&A question answer on top of the existing model, Falcon model. So how we do the fine tuning, I'll walk you through. So we'll be loading the model. So we'll be having, this is the sharded version of BFC16. So BrainFloat 16 model for Falcon 7B. So sharding is a framework in like basically it is done in Python. So how models are sharded is they are basically parallelized in the GPUs, and they also shift the weights to CPUs. They offload the memory. So while training, it it saves 60% of the memory for the model when we load the model. So it is less memory intensive, and it would be faster in training. So so in bits and bytes, we load the model. We define the normal float for a 4-bit quantization type, and these are the configurations. Model is we will be loading this model and using the existing code. So this once we load all the model weights, we'll be using bits and bytes and this. So these all the model files and sharding. These are the checkpoint shards, which are the sharded bits. So those are loaded. We also need the tokenizer for this. So all the vocabulary and all the dataset relevant tokenizer files. So these are particular to the model which we'll be using. So this would be downloaded, and we import LoRa configuration from the PEF library. So quantization is one which we talked Q, and the LoRa. So LoRa encode adaptation, so which will be importing through the parameter efficient PEF library. So these are the parameters for the LoRa configuration. So this is the these are the dropout, and these are the parameters basically, and I'll walk you through. Yeah. So this would be wrapping up around transformers or this model. So how we train this? So batch size would be 4, gradient accumulation. So what is the gradient you want to accumulate over how many steps basically? So that is also decided to be 4. Optimizer is Adam 32-bit optimizer, and this is the learning scheduler. You can play around with the learning rates as well. So a smaller learning rate will take will learn better, but it will take a lot of time. And faster learning rate means maybe it will forget. It will cause forgetting issues also. So you need an optimal learning rate for the training. And so when you
Just
train,
increase
yeah,
a notch, increase the font size just a notch.
yeah, sure. Should I, if this is fine, zoom in?
Yeah, this is fine, I think.
Yeah, yeah. Is it visible to everyone? Yeah, it's
Yeah.
fine. Yeah, okay. Yeah, so these are the training arguments. So what we have is the gradient accumulations, what we have defined, the number of epochs as well. So max steps, like how many steps you want to take. FP16. So this is we want to convert back to the FP16 model once the training is done. So we have defined that, and the learning rate scheduler. So this is given here constant. So it can be different cosine. There are a lot of learning rate schedulers. So how basically you want the learning rate to learn, a model to learn? That is through a cosine wave, or like how it is defined mathematically. So lot of learning rate frameworks. So once we defined a maximum sequence length. So the tokenizer, how many tokens from the text you want from the data set you want the model to learn at each epoch, or maybe this. So this is the maximum sequence length it can take. for the training, and output will also be basically till this maximum sequence length. So uh, we train the model on the data set. We keep all these arguments, and uh, I'll move on to training. Yeah. So we train the model. Uh, I don't have the currently the all the training data. I'll share that. But so basically, this runs for a 500 epochs. So these are the total number of maximum steps, and these are the total 3 epochs. So this would be repeated for 3 times. So it takes around 3 hours, 23 minutes. But depending upon your GPU and computation, it can vary for from the data set also, and model you take the model weights also, the training will time will differ. So this is uh, how the process works. And so the loss, training loss, as you uh, 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 increase the number of training, the loss decreases. So you can see a nice curve here, and how that's how you basically visualize the training model. This is done usually through WNB.ai. So you can use one.b.ai for this integrating this and getting a visualization of your model. So I'll move on to a Llama model continuing. Good. Yeah. So this is basically how you fine tune Llama 2 on this uh, Dolly 15K Databricks Dolly 15K dataset on this using this is created by Guardrail ML. So that's also a framework for governance of the ML models. So here also you need a lot of dependencies. So accelerate, PEP, bits and bytes, transformers, TRL, Guardrail, and TensorBoard. So TensorBoard is similar to what we used in here, WNB.ai for visualization of the model files, training them. Yeah. So you need particular versions of these libraries for because if not, they'll conflict and they might cause errors. So yeah. Once we import all these required transformer dependencies, pref configuration module files, and this we use see this local rank parameter is -1, so it is for device mapping. So how you want for multi GPU training. So since the model size dataset size is quite huge, 15,000 rows dataset. So for that you need multi GPU training instance. So uh, the batch parameters uh, will be varying. You can change it and optimize it as per your GPU and model workload. So these are the configurations. So data set. So I'll walk you through this. This is the guardrail model of this Llama 2. We fine tune model. We rename it, and this is the data set we'll be using. Databricks. Yeah. So um, this is the optimizer. This is the learning rate scheduler, and these are the number of steps we'll be taking. So we'll be reporting the training to TensorBoard once the training is finished. So we load the model and shards. Once that is done, we'll we'll import the tokenizer files, and we'll fix this for FP16 file load 16 bit. Yeah. Uh, for this Dolly, the dataset needs to be formatted in the right way because Llama and Alpaca modules, Llama 2 modules and Alpaca modules, these need an instruction tuned dataset. So it should be in the right format for the model to proceed. So you cannot just simply take any dataset, but if even if you take, you need to format the dataset in the right way in the JSON-L format. So for the model to take the instructions and this properly. So this is the how you format the function, and once you load the data set, we will shuffle that data set randomly and will load. So device map and this is data set mapping is done for uh, understanding and removing the unnecessary columns also. So once this pre-processing part of the data set is done, we'll pass all the arguments, required arguments to uh, the trainer and we'll train the model. So uh, this training we have done 100 steps for 100 like total epochs maximum steps of one. So it is uh, it is quite fast here because they have used like uh, faster GPU instance probably. So uh, so this is the training loss for each step. So it has been shown like we can see it is converging to a lesser loss. So we can see that. At the end of the 100 steps is very less significantly. The training has been successful. So in terms of model training, we'll need to prompt it to test it more. So once with training is finished, we'll load the tensor board. So it basically gives you the model visualization as the graph analysis. And once that is done, you can we can save the model files and the LoRa computation and can get the model back to FP16 from the quantized model. So we are converting back to the base model like with adapter files and the base model. So we'll get the final model file and we can have a prompting question answering and this. So if we ask it why can camels survive for longer without water, so it can
Yeah,
answer
yeah,
better. Yeah,
that's prompt for questions. Audience, feel free to interact and ask more questions.
yeah, sure.
There's a lot of extensive code discussion, so
Yeah,
I hope people are getting it. So audience, if you have any questions, feel free to ask.
yeah. Please feel free to ask.
One question. So, will we be getting this code collab file after this presentation?
Yeah, yeah. Vivek, no, like
No, I mean, if it is Mihir, if it is part of our product IP, then we will not be able to share. But if you are showing a separate code demo,
yeah,
which is
if I can share a code demo which is relevant to this, I'll share the file, but only the part which like we are developing for our product, I won't be able to share. But regardless of that, like if any tutorial or any references would be there, I'll share that. Sure.
Okay, sure.
Yeah.
Thank you.
Okay. Any other question? Or I'll move on. Yeah.
One more quick question. The Llama 2 you are saying you are
Yeah.
showing, right? So
Yeah.
it doesn't need any API to be called, right? Like it's an
No, no,
open
no.
source, right? Not commercial.
Yeah. It is. It can be used for enterprise. So it is open source, and Meta has released this model, and it is available for like on the Hugging Face only. You can check it out. The
Okay.
model
So
weights are
so one
available.
quick
Yeah.
question here. So when you say open source, there's a small confusion from my
Yeah.
end. When you say open source, do you still call that API in order to do something? Like let's say OpenAI has an API, right? That they
Mm-hmm.
call like somewhere I have seen. So that's why my
No, no,
confusion.
no.
Yeah.
Like first for loading the model weights, you need the Hugging Face or maybe a hosted somewhere on the GitHub or you take the model files and once that model is loaded, you and it is fine tuned, you can push it to the Hugging Face hub or you can do the inferencing on yourself. So that no API is needed there. So you can
Okay.
host it somewhere and uh, uh, that's a later part, but inferencing can be done without any APIs required. Yeah,
Okay. Thank you.
yeah, sure. Vivek, if you can just read the questions.
Yeah, you can check the question.
Okay, okay. Next generation task we use. Yeah, yeah, I can understand. So these are the like top K rows and top peak. Like basically, you are saying uh, choosing the data from the data set. Is it, Siddesh? Uh, if you could unmute and if you could. Yeah. Okay, okay. Yeah. So selection of that, like instead of me randomly shuffling the dataset, we could use the top key and this parameters for selection of the dataset. So it might uh, uh, help a little in the uh, accuracy and aspects, but it is always better to have the dataset randomly shuffled. So that is how you usually uh, train the model. So that is uh, K selection and K based like shuffling and randomized shuffling techniques. These are used better. So for any like text generation, text classification. So depending upon the task, also it might vary. Yeah, yeah. Vivek, should I move on?
Yeah, go ahead.
Yeah. So these are like the prompting what we have prompted here. So. Uh, we it we can see that it is giving the right answers for the questions. So what issues here maybe like we find is for non-contextual questions maybe it should not lose out on the knowledge. So even if we fine tuning using this like QLoRa and PEFT, it makes sure it doesn't lead to catastrophic forgetting issues because we are just freezing all the layers and we are just fine tuning the last few layers. So it won't lose out on the core information the model was trained on. So it will be fine tuned on the specific domain knowledge or tasks, but even though after this also it won't be able to it won't lose out on the uh, knowledge. Yeah. So we yeah, so I'm done with the demo and just Vic, let me know.
So yeah, we can discuss bit more on the papers. So
Yeah, sure.
the two papers you were showing,
Yeah,
we
yeah,
are very,
I'll move on to the paper. Yeah, sure.
yeah.
So this is the Llama 2 paper. So we can have a look at this also. Yeah. Uh, so this is released by Meta. So this is the team. So they have mentioned about the models. So model size ranges from 7 billion to 70 billion parameters. 70 billion parameter one currently is beating all the similar LLMs of this. When the Meta like Llama 2 was released, it is the highest parameter one is beating the accuracy and metrics. So I'll talk about that also. Yeah. So how this model was trained, so we can understand this. So for the training, they have used RLHF also, reinforcement learning through human feedback. So that is one aspect uh, uh, in the training. They have used the reward model for safety fine tuning. It should not uh, uh, just say any other use
Mihir,
language. Yeah,
so ChatGPT was enhanced with RLHF, right? That's
yeah,
why
yeah,
ChatGPT was more sophisticated from beginning.
yeah, yeah.
Now, are you saying, see, Llama 1 was not trained with RLHF,
Yeah,
right?
Llama 2 is yeah,
Llama 2 is trained with RLHF. So they
yeah,
copied the ChatGPT strategy, huh?
yeah, yeah. For the safety aspects, a lot of this, including Clouder model from the Anthropic, they are also fine tuned for safety and alignment. So alignment, fine tuning, and safety. There are a lot of this guardrail ML and runway ML and other like companies, and this they have designed solutions for this.
Right.
And reinforcement learning with human feedback. So manually giving the labeling and with by human and using reinforcement learning on that top of that. So it can be useful for at the end as a reward model.
Right.
So
Right.
after the initial fine tuning is done. Yeah. So safety evaluation. So we can see uh, violation. So violation percentage is lower is safer. So there. Uh, given. ChatGPT is still, you can see here at the end, and the Llama 34 billion one. So it is almost equivalent, but other models, even though 70 billion one, it is quite good in terms of safety and this. So I'll move on. So how the pre-training is done? They have used a few data sets on the for the pre-training. So once the pre-training part is done, so pre-training is expensive. So the main training is in pre-training. So stage fine-tuning does not is quite inexpensive or is very less memory intensive as compared to the pre-training of the original model. So this these are the current parameters. These are the context lengths for which they can handle the tokens, and so these are the how many tokens they were trained on. So 1 trillion, 1.4 trillion, and these are the optimal learning rates they use. So this is for Llama 1 and Llama 2. So grouped query attention framework, that's also one technique they have used for the Llama 2 larger models. So uh, you can see the uh, token size and training graph here also. And yeah, so these are all the models like MPT, Falcon, Llama 1, Llama 2. So on these sizes, and when asked questions on common sense reasoning, world knowledge GK, and mathematical languages, these are the accuracies they achieved. So we could actually see for a lot of tasks, Llama 2 is significantly uh, uh, improved on their base model. So on top of Llama 1. So there, yeah. So fine tuning techniques are there. So supervised fine tuning. So here, this is sort of we can understand how the instruction fine tuning also works and how we should prompt. So this is like when a query is asked, like write a poem for this. This is the response. So and uh, this is safety fine tuning. So if we ask any question which is not actually should not be asked, or language is restricted, so it actually says I don't know, and I'm sorry, I can't do this type of task. So this is done for safety reasons, and this is fine tuned on top of the existing one. Yeah. So quality they have taken care of using techniques, and safety fine tuning in RMS. Yeah. And reward modeling, that is reinforcement learning they have used. So how the cloud models, cloud 1 and 2 from Anthropic, they have also then there's other metrics for safety. So you can have a look at this paper for more details into this. And yeah, that's basically going into this. And I'll talk about more about the parameter efficient fine tuning. Yeah. So how basically PEFT works is you take the initial model weights, you do the prediction, you get the results, and then you feed that results back into the model, and train the model on a like the fine tune the model on the adapter weights. Basically, you fine tune, and you get a new set of adapter weights which are updated, and then you make another prediction, and then this process repeats. So this basically is how fine tuning works, and so there's a feed forward layer, and so you can I'll share more. Yeah, these are the total number of parameters. These are trained parameters. So how many actually parameters was needed to be trained? So you can see just for the adapters, you just need to train only 3.6% or 2.1%, and on so existing model, all the 100% parameters were trained. So for fine tuning, you don't need to train it significantly. It is quite less parameters. So it will be quite faster. So yeah, these are the graphs for how the fine-tuned top layers and existing adapter weights and how it works. So you can. So this is a squad data set from Stanford. So question answering data set. So, uh, so there's like a lot of ML techniques like multitask learning, continual learning. So continual learning is also one technique which is used. So how it model should learn continuously. So so catastrophic forgetting, as I talked about this. So how the model should not forget the existing knowledge when it is fine tuned. So uh, continual learning or this when actually it is retrained, uh, deep networks tend to forget. So how you solve these issues? This is a quite a good research area to work on. And uh, yeah, I'll stop and I'll keep question. Vivek? Yeah.
Yeah, we can have an open discussion. So,
Yeah.
audience, any thoughts, questions, or just discussions you want to do?
Yeah.
So, what are the various fine-tuning techniques? One is PEFT. What
Yeah.
was the? There is QLoRa, right?
Q
What
Laura,
else?
like yeah. So more on this would be mm, like these are the main like currently used techniques. So
What about
uh,
instruction fine-tuning, which I found on Chat
yeah,
GPT website?
yeah. So instruction tuning and soft prompting. So prompt tuning also. So how that works? Like so prompting is like for you can we can have the model to output the right response once it is trained. So how we can uh, like get the right output from the model. So that is done through soft prompting, hard prompting, and like prompt tuning. So prompt engineering is one subjective field for that. And so and instruction tuning. So instruction tuning is what is used like for fine tuning these llama models, llama 2 models. So with the data set which we are using for fine tuning this llama 2 models, this is instruction tuning data set. So it is an alpaca format. So the Stanford's alpaca model and these llama models, these are designed in the same way, and their structure for the data set is requirement is in the same way. So uh, that is
So
how is yeah, yeah,
Alpaca by Stanford was trained, on Llama 1
yeah,
using instruct fine-tuning process, correct?
yeah, yeah.
Now, has the Alpaca team enhanced Alpaca to work with Llama 2 yet or not?
Uh,
I haven't
as
seen
far
any
as
communication.
yeah, yeah.
I haven't seen any communication whether Alpaca has been launched for Llama 2, correct? Because Alpaca still works with Llama 1 only.
No, no, no. It is the Llama model is basically on top of the existing alpaca model. So it hasn't been updated from then
Correct,
because
correct. So,
yeah, different model structures that have been released. But alpaca, that one thing about alpaca is they have synthetically created their data set for the training. So
hmm.
synthetic data generation. So that is how we can also curate the data for llama to and these models. And
No, the
this can
question
be used.
is
Yeah,
for Llama 1, I had a conversational layer in form of Alpaca,
yeah.
right? Now, for Llama 2, is there a conversational layer or we have to build it?
So it is there existing in the existing model also, and uh, we can fine tune it also. So that is we can have it on the existing model also. So that is there because
Can you show
it
the
is a yeah,
Guanco? You are developing a Llama 2 product on Guanco dataset fine tuning.
yeah, yeah. I'll
Can
share the
you show
data
a
set
view
if
of
you want.
Guanco dataset? Just show a view of how it looks like.
Yeah,
What are the sample, data in Guanco
yeah.
on which we
So
are
this is
basically.
the yeah. I'm showing the entire bigger size data set. We also have the 1,000 row data set also for this. This is the bigger data set which is released by
Can
the
you increase the font a bit?
yeah, yeah, sure, sure.
So is it just Q&A basically?
Yeah, so it is. Uh, yeah, so it is a Q&A question answering data set. So from along with the translation tasks, then asking it to generate the text or an essay, or optimizing this web page for this search engine SEO, how you can do that. So it learns this
Can you increase
yeah.
the font? It's not readable.
Yes, really sorry, but yeah, I'll try.
Just say Control plus if it is Windows.
Yeah, it is
Then
Windows. Yeah, sure.
yeah.
I will try to. Uh, no, it is.
Okay, that's okay. You
Yeah,
continue.
yes. Sorry, but yeah. Uh, so on the existing knowledge, it is trained for these text based tasks more. So it can act as a assistant. So this is an open assistant like similar dataset, and there is a smaller version of this dataset also available. So this is around 10,000 rows, and 1,000 rows is also available. So if it is a smaller model, you don't need to use a larger dataset, or it is up to you, like how much it will significantly improve your accuracy and training. Yes. Yeah. Uh, MPT model we looked at, it is a release from the Mosaic ML. So they have released many frameworks also for safety fine tuning also, and uh, this and other models also are there. So dataset, and we can yeah, this is the main data set which was used for the llama 2's fine tuning, which I showed. So this was used, and this author is the one for the QLoRa's paper. Tim did. Yeah. Any other question?
Okay, so Amir, one question I had about the
Yeah.
Imagine GPT product.
Mhm.
We are launching the Llama 2 product in Imagine GPT stack.
Yeah.
Then Bismillah is working on the URL miner, and Kanjika on the PDF and URL miner,
Yeah.
right, and YouTube miner. Now, is there an opportunity to apply RLHF in Imagine GPT, or we it's irrelevant for us because RLHF is already applied on the foundation models we are using for all our products?
Yeah, that's quite a good question. So basically, uh, on the foundation models like Llama and Llama 2, basically, and like GPT based models. So not maybe Llama 1, but for these models, the reward model, it is already trained on this. So uh, um, just the question arises, when you fine tune on the top layers, will it lose out on the safety aspect, or maybe what it is trained on using RLHF? So when we test it, it actually preserves all the safety and requirements and
So
RLHF.
there is no need for RLHF in
Yeah,
Imagine
yeah,
GPT
it
so
is.
far.
When you use the same foundation model, it is not needed.
Yeah, understood. So any other questions, audience?
Yeah, open to questions.
So you can see our upcoming product Imagine GPT. We are looking for top product contributors who can help us develop a suite of LLM products on this stack. So if you have a hands-on expertise in LLM development, then contact us, and we'll discuss your contributory role to this product. Of course, all of you are members of our community, and if not, then you are welcome to join the community. Contact me. My number is given in the chat. Any other questions for Mihir? Mihir, are you done from your side?
Yeah, I'm done from my end. I'll be open for questions.
Any comments or questions, folks? Okay, so thank you all for joining. And Mihir, thanks for this presentation and your hard work.
Yeah,
And we'll look into your next set of presentations. Yeah.
sure. Thank you.
Thank you all.
Thank you. Thank you, team.
Thank you.